So playing with geometric patterns here we go. So I have a sequence of these pattern blocks here, and what I want to do is just get an idea about how to continue this, and then can I then name properties of this sequence for, like, what's the 100th one going to look like? How many greens will it have? How many oranges will it have? So we're just going to kind of play around with that pattern. So I'm going to make, let's see, a screenshot of this so I can scribble on it and write down some of its properties and see if I can extend them. See, I got a blank page, good. And screenshots. All right, so here's my pattern I want to play with. So I'm just going to first start by labeling these. This is going to be my first one, and that's my second one, and that's my third one. That's my fourth one, and that's my fifth one. And you noticed before, when I'm trying to organize my thoughts about a problem, a table is almost always helpful in so many different problems. So I'm going to make a table off to the side to keep track of some stuff. Ooh, that wasn't a very straight line. Wasn't holding my tablet in my hand correctly. So what do I want to keep track of? I want to keep track of n. I want to keep track of the number of shapes. So I'm just going to call that number shapes. I want to keep track of the triangles. And I want to keep track of the squares. So the first one has one shape, one triangle, no squares. Second one has two shapes, sorry. And that's one triangle, one square. The third one has three shapes. It has two triangles and still one square. The fourth one has four shapes, pretty consistent there. Two triangles, two squares. The fifth one, five shapes, cool. And three triangles and two squares. And then I want to see, can I identify some patterns here? Do I need to draw some more shapes? Sometimes I do. It kind of depends on the situation I have. So what would the next one look at? Well, it looks like we're alternating, right? Square, triangle, with the new one on the end there. So I'm thinking the next one just needs another square. So I'm just going to write that I believe the sixth one is going to get an extra square. So that's going to be three squares. It's going to still have three triangles, and it's going to have six altogether. And I'm going to guess at the seventh one. So let's see. Square, triangle. I just added the square, so I'm going to have to add a triangle. It's four triangles. I didn't add a square. There should be seven of them. 4 plus 3, that's the seventh one there. Now, not too bad. I can keep figuring out what's going on. So the eighth one is going to add, it's going to have 8 shapes, right? And then notice the pattern, 1, 1, 2, 2, 3, 3. So this should be 4. The triangles stay still, and then the squares are going to get another one. So that's going to jump up to 4. 0, 1, 1, 2, 2, 3, 3, 4. That seems reasonable. I'm going to highlight some things, or maybe circle, help me keep track. So let's see. I started with one triangle, and then I added a square, and then I added a triangle, and then I added a square, added a triangle, added a square, added a triangle, added a square. So the circle means I added that shape. And my brain just felt like I needed to see that zigzag pattern in adding triangles and squares. Okay, let's do another one, just make sure we got this down. The ninth one should have 9 shapes. Last I added a square, so this time I better add a triangle. And the squares stay the same, and I'm going to circle that 5 because that's where I added something. Okay, so I'm starting to get a feel for this pattern here. So can I make predictions about the pattern? Well, what kind of predictions would I like to make? Well, what does the 100th one look like? Okay. Question mark, what does it look like? All right, so I got to figure out, does the 100th one, did it end in a square or a triangle, right? Because those are the only options, square or triangle. Well, let's see. I circled the last thing I added, so that's the circle is also how it ends, right? Ends in a square, ends in a triangle, ends in a square, ends in a triangle. Is there a pattern to when I ended in a square? Let's see, I ended in a square on the second shape, right? I ended in a square on the fourth shape. What do you think, Lexi?
Well, obviously, every other.
Yeah,
You
every
ended.
other one. So is
It's.
100 going to be a square or a triangle at the end?
I think it's gonna be a square because all like a pattern I'm seeing is all the evens end in a square. Like you
Yeah,
add a square every even number.
yeah, every other one starting with 2, which makes it always even. Okay, so that's an excellent observation. Okay, so I'm just going to make a note, ends in square, every, that's right, other starting with second. So I could say, oops, that is even. 100 is even, so it should end in a square. Okay, so I think I can describe the 100th one pretty good. The 100th, and I'm just going to kind of sketch out my ideas here based on what you said and what we see there, the 100th figure. Now, all of them start with a triangle, so that's easy. I'm going to start with the easy part. Starts with a triangle. Ends with a square. What else do I know? Well, the total number of shapes is always the figure's position in the list, right? The second one had 2, the third one had 3, and so on. Okay, so we know that too. Has 100 shapes. Okay, let's see, can I say anything else? Can I say how many of each it had? Okay, so what's that?
When it ends in a square, it's the same number of shapes.
Yeah, same number of triangles and squares. Yeah, totally cool, right? So it ends in a square, we have 1 plus 1, ends in a square, 2 plus 2, ends in a square, 3 plus 3. Cool.
It's also half of what the shapes are.
Oh, it's also half the number of shapes, right? They have to be equal. So there's a few different ways to say that. So that's kind of cool, right? You both described the same idea, but in different ways, right? There's always different ways to talk about this stuff. And it's good as a teacher to know different ways to talk about it, because one kid sees it one way and another kid sees it a different way. So the more we know, the better we can help people figure stuff out, communicate. So let's see, starts with a triangle, ends with a square, has 100 shapes. And we could say half of them are triangles and half of them are squares. We could say there has to be 50 triangles, there are 50 squares, right? Lots of ways to go on from there. So I'm just going to pick has 50 triangles and 50 squares. And let's stop there, put some commas here. I got a nice sentence about the 100th one, right? So I should be able to then pick any number, like what's the 1000th one going to look like? What's the 353rd one going to look like? And we should be able to describe it based on the patterns we saw. And important thing here is we have to find a way to help organize our thoughts, and tables are pretty powerful ways to do that. And we had to add to the table, right? We had to circle stuff and point to stuff to make it more obvious. And again, there's many different ways to do that. And mine isn't necessarily the best way. There's just lots of ways to do it. Okay, so I'm gonna stop here for a second.
So this one we don't necessarily have to try and find like an equation for it.
That's a good question. So we could find an equation for, let's see, we could find an equation for the number of triangles or the number of squares. Yeah, let's do that just for fun. Let's see, how do I turn that off? Okay, so we're still recording. And again, equations are nice and sometimes they're good and sometimes we really don't need them, but let's go for it. Now, this is interesting here because we have these repeated numbers. Okay, so what are some things we know if we wanted to come up with some formulas? So one formula is the number of shapes. That's just n. That's super easy. That's not hard. But identifying how many triangles and how many squares are, that's a little harder. So let's do how many triangles are in the, I'm just going to say the nth figure. Question mark. Now, what we can see from our table is, well, that kind of depends on whether n is odd or even, right? If n is even, I didn't get to add an extra triangle, but if n is odd, I did get to add an extra triangle. So we're just going to have to play around with that. So let's just play with the triangles to answer this question. And I think I need a new page to answer this. So let's grab that question, stick it on a new page. And move it up. All right. So that table had a lot of information, so I'm just going to kind of look at the information I need to answer this question. I just need to keep track of n and the number of triangles. So n versus triangles. And so first one had one triangle, second one still had one triangle. Third figure, we got to add an extra triangle. Fourth figure, we didn't, right? That was still two. Fifth figure, let's see, we did get to add a triangle. Sixth figure, we added a square, not a triangle, right? So just keeping track of the triangles here, right? 1, 1, 2, 2, 3, 3. Let's do one more, two more. The seventh, we got to add a triangle. The eighth one, we did not get to add a triangle. All right, and then you guys made some great comments that if it's even, there'll be an equal number of triangles and squares, or if it's even, the number of triangles is exactly half. So let's make a note of that. If n is even, then how do you do half? You just multiply by a half or divide by 2. So then there are n over 2, right? Triangles. Let's test that. So if I pick an even number like 8, that's my n, then the triangles should be 8 over 2, which is 4. Okay, cool. What if n is odd though? If n is odd. Well, let's pick on 7. 7's an odd number. And I try the divide by 2 thing. Let's see if I take for triangles and I say, let's take 7 and divide it by 2. That's going to give me 3.5. But I wanted the answer to be 4, didn't I? All right, let's try n equals 5. If n equals 5, then the triangles are they going to be related to 5 over 2? 5 over 2 is 2.5. I wanted it to be 3. So is there a way I can tell somebody what to do there? There's a couple things that come to mind. One, I could say divide by 2 and then round it up. That would work. What else? If that 7 were an 8 instead, then I would get 4. If the 5 were a 6 instead, then I get 3. All right, so I see a couple different options here. One option is to say, hey, if n is odd, divide by 2 and round it up. Why not, right? We round all the time in math. So that's one procedure. And the other procedure, I think, would be to take n, add 1, and then divide by 2. So for example, if I take 7 plus 1 and then divide by 2, that gives me 8 over 2, which is 4. So since we're not adding a triangle every time, it seems like there needs to be a rule for when it's even, and there needs to be another rule for when it's odd. Okay. And it's a little more complicated. So we have two versions of the rule. One of them is the one I have right here. I'll have n plus 1 over 2 triangles. And the other one I voiced but didn't write down, I would say divide by 2 and then round it up. Okay, so I could write that down separately. Triangles, if n is odd, find n over 2, then round up. Example, n equals 7. Oh, it's supposed to be a 7. Sorry about that. 7 over 2 is 3.5, which rounds up approximately to 4. So there must be 4 triangles. Cool. Thanks for asking that question.